Hi guys, welcome back to Module 6. In this module, we're going to cover iterative executions. So let's first have a discussion about what they are and how we can use them in our Python coding. So iterative executions are repetitive executions of a block of code. So it's a block of code that we want to repeat until we have a condition that is met, or until we specify how many times we want to repeat the code. So there are two types of iterative executions, which are definite and indefinite. So definite iterations, we know in advance how many times we want to run the code or how many times we want to repeat the runs. And for indefinite execution, indefinite iteration, we want to run the code until we have met a certain condition. So we don't know in advance how many times we want to run it, but we run it until a certain condition is met. So for definite iteration, we use for loops, and for indefinite iterations, we use while loops. In this module, we will cover both kinds of loops, and we will explain how we will use it in our Python coding.
So now we're going to cover for loops. Like we said before, a for loop is a way to go over a list or a tuple or any sequence, and you can perform an operation on each element in that sequence. And you tell the block of code beforehand how many times you want the block of code to be run. So here we've created a list called numbers, and we're starting our for loop with for I in numbers, where I is a loop variable that is going to represent each element in the list. So for I in numbers, print I. So in this code, we want to print I for every element in the list. So it's going to be printing 1, 2, 3, 4, 5. So let's run the code. And 1, 2, 3, 4, 5 comes out, so that's good. And now we're going to cover the break statement. So when you're in a for loop, if you want to go out of it, you can use a break statement. And to show it, we've used a list, and we've created a list of minerals. So there's quartz, feldspar, and olivine. For X in minerals, print X. And inside the loop, we've created an if statement. So if X is equal to feldspar, break. And break means that the loop will exit, and then you're out of the loop completely. So let's run the code. So here you can see in the output that when X is equal to quartz, it's printing quartz, and when X is equal to feldspar, it's printing feldspar. But when it's equal to feldspar, it also tells it to break, so it exits. So that's why it's never printing olivine. Here is another example of a break statement, but in this case, you exit the loop before the next iteration and not after. So as before, for X in minerals, if X is equal to feldspar, break. So that means that it won't be printed. And then you print the X after. So let's run the code. And there, as you can see, it's printing quartz because quartz is before feldspar, but when X is equal to feldspar, it breaks the loop right away. Now let's continue with the continue statement. And this statement is used if you want to skip an iteration. So we're using the same example again with a list of minerals. For X in minerals, if X is equal to feldspar, continue. So when we're using continue instead of break, it skips that iteration and goes straight to the next one. So let's run the code. And as you can see, it's printing quartz, and then when X is equal to feldspar, it skips it and goes to the next one and prints out olivine. Now let's cover the range function. So the range function returns a sequence of numbers starting from 0 by default and increments by 1 by default, and ends at a specified number. So now we're going to print numbers from 0 to 7 using a for loop. For X in range 8, print X. So let's run the code. 0, 1, 2, 3, 4, 5, 6, 7. And remember, it prints 7 because it's up until the 8th element, and that's 7 because in Python it starts at 0. So now let's cover how you can use the range function in different ways. So you can also use the range function and determine the starting value and the ending value yourself. So here we want to count from 2 until 8. So for x in range 2 is as the starting value until 8 as the ending value, print x. So let's run the code. And here it's printing from 2 till 7. And another nice thing you can do is that you can choose the step size. So in this case, where for x in range 2 until 30, we want to print every number, but with step size 2. So let's run the code. So it's 2, 4, 6, 8, 10, and so on.
Okay, so now we will talk about while loops and how we can use them in our coding. So the while loop will execute a block of code until the condition that we stated in the loop is true, or until it is met. So it is useful to repeat a set of instructions until, if we don't know how many times we want to run it. And for example, we can use this while loop to prompt a user to put an input until the value is valid. So for example, if we want to create a code where the value has to be more than 0, and the user keeps putting a negative number, a while loop will be useful in this scenario. However, you need to be careful when it comes to while loops, because if in your code you don't have a statement that will break the loop, then your code will run infinitely. So meaning to say, if you don't have the condition being met, or if the condition that you stated in the loop is never met, the program or the code will run continuously. And this can cause it to fail or hang, or it could cause the runtime to be very long. Now we will look at an example of a while loop. So first, we want to print I as long as I is less than 6. So we have a line of code here. First, we define I equals to 1, and then we start the while loop. So we say here, while as long as it's less than 6, while I is less than 6, we want to print the value of I, and then the line here is a counter, and then we will add I with 1, and then it will go through the loop again. So if we run this code, we can see all the values that are less than 6 is printed. So we have 1, 2, 3, 4, and 5. Next, we will look at the usage of break in a while loop. So first, we specify I, which equals to 0. And then while true in this line, it means that as long as the statement is true, it will go through the loop. So here we say if I is greater than 5, then we exit the loop. If not, we have to print the value of I, and then we have a counter. So we add 1 to the value of I. And then if we run this line or this code, we can see that we have all the values from 0 to 4. And the moment when I is equal to 5 or greater than 5, it breaks and it exits the loop. Next, let's look at an example of using a while loop with continue. In this example, we want to use a while loop to print all odd numbers in a range. So the range that we have is from 1 to 10. So we define two variables, which is start and end. Start equals to 1 and end equals to 10. So here we start the while loop where we say when start is less or equal to n, and then we have a condition. If start is divisible by 2, we add a count, we add 1 to start, and then we skip the iteration by using continue. Else, if it's not divisible by 2, we will print that value of start, and then we add 1 as well to the counter. So let's see what happens here. When we run the code, it prints all odd numbers from the range of 1 to 10. So the use of continue here basically skips all even numbers, and then it prints all the odd numbers. So whenever it's an even number, when start is an even number, it will skip through the loop, and then when it's an odd number, it will print it out in the output.
And now let's cover nested loops. So a nested loop is a loop inside of a loop, and the inner loop will be executed one time for each iteration of the outer loop. So here we've created a list of numbers, and we want to create a timetable. So I'm going to try to cover how this loop works. And this loop is going to loop over each number combination. So for num1 in numbers, so for the first iteration of the outer loop, it's going to be 1. And when num1 is num, it goes inside the inner loop, which is for num2 in numbers. the product is equal to num1 times num2. So it's multiplying the numbers together, and then it's printing. So in this case, it will be 1 times 1 equal 1. And then when that is finished, it's going to go to the outer loop again, no, the inner loop again, and go to 1 times 2 equals 2, 1 times 3 equals 3, and so on. And when the inner loop has gone all the way until 5, it's going to go out to the outer loop again. And then the outer loop will change until 2, and it will go to the inner loop, and 2 will be multiplied by all the numbers in the list, and so on. So this way we're going to get out the full timetable, multiplication table, 5 times 5. Let's run the code. And as you can see here, it's printing out 1 times 1 equals 1, and all the way until 5 times 5 equals 25. That was all we had for Module 6 and loops, so hope to see you in the next video. Thank you for watching.